Yes. Ah! Hello! Welcome to this video. Today we're going to be making some 68% nitric acid from these materials. Now, before we start, there's a little warning. Do this outside or in a fume hood because nitrogen dioxide isn't that pleasant. So just do it where there's kind of a lot of ventilation so that doesn't get too nasty. So, what is nitric acid? It's a mineral acid. It's very, very, very important when you're doing chemistry, so you can make nitrate compounds and other things like that. So the procedure that I'm doing is as follows. So you require 100 milliliters of water. I'm just using distilled water. 120 milliliters of sulfuric acid. I'm just using low-grade drain cleaner, 91%. It's one shot, I believe. Yes, it's one shot, so pretty common. And then it also requires 202 grams of potassium nitrate. I just bought some on Amazon for cheap. And then you also require distillation setup like this. I'm using a heating mantle. I don't think if you use a hot plate stirrer that it will get as much heat as it requires to come over, so better safe than sorry, just use a heating mantle here. Hello, Editing Sebastian here. I just realised that I actually used 200 milliliters of water and not 100, but it does work exactly the same. And also, I should point out, do not use nitrile gloves, only use vinyl gloves. That's what I'm using there, because the nitric acid will chew through the nitrile gloves like paper. So yeah, that's all from me. Enjoy the video, please subscribe, bye! Right, the first thing we want to do is get the water, should I think? I can't think today. Let's get the water into the system. So I'm going to charge it with this water. I'm just using this glass funnel here. Like that. I've also, just before we start, I've also got a stir bar in here just to prevent bumping and things. It also just helps generally to have a stir bar. Then we're going to get a dry funnel, dryish funnel, should I say, and charge it with potassium nitrate. Now, if you're wondering what's the general size of my adapters that I'm using is, I'm using 1423. I've had 1423 stuff for years, and I'm hoping to save up to upgrade to something more like 1926 or 2429, so it's just a bit bigger, just a bit nicer to work with, but you know, to have adapters for everything. There we go. Just a tiny bit of nitrate to go in there. Let's just wash the beaker, a bit of distilled water in this little squirty bottle. Just wash that into there. Make sure we've got everything out. Just make sure to grease this with a bit of distilled water, and then comes the fun part. We're going to turn the stirring on now, and we're going to just grease this. I'm just using Vaseline, doesn't really matter at the moment. We're just going to grease this adapter, so 1423 to 1926 adapter. Just spin it round. When you're using glassware like this, always better just to spin it round a couple of times in the socket to make sure everything is nice and greased. So I'm going to fit this pressure equalised addition funnel to it. Let's just clip the adapter so we get a tiny bit of extra security. That should be fine there. We're going to use this funnel here. Doesn't really fit, but that's fine. We'll make sure that the stop clock is closed, and I'm going to pour. go over here. And we'll start to open the stopcock. Now this is very exothermic, so it produces a lot of heat. So we'll just make sure to do this nice and slowly. There's my dog in the background barking. That's not a necessary component of any lab, but it is certainly a good one. As you can see there already, there's some gases coming out. So we're going to remove this, take out this adapter, put the stopcock on. Now, here's the part where you need the respirator, just in case something absolutely atrocious happens. And once we've done that, we're going to put the water on, or the condenser. I've just got a little fish tank pump in a bucket below. I can show you a bit while the distillation is running. And we're going to turn the heat up to maximum. I'm going to let this distill for a while, just while it reacts and produces our crude nitric acid. This will take a while, so you should always just kind of monitor it, especially this one. I've had quite a nasty experience with nitric acid before. I've just talked with my respirator off. A nasty thing happened, which was that the stopcock go off. So that was nice. So just make sure you monitor it. I've got a little vent here, so any gases can come out. Obviously we don't want a massive hole so that all the nitric acid can escape. It's always better to just have a nice vent somewhere in the system. This monitor isn't necessary, but it's nice to have. Now, obviously, I haven't got a thermocouple probe yet, so I'm just using this old-fashioned mercury thermometer. If I'm shaking, that's because I'm positively terrified. So yeah, that's what's going to happen there. Just close this. We can move all this off. I'll put my respirator on, and we can have a little time lapse of the distillation. So I'll see you then. See here, but we can see a reflux happening on the side of the flask, which is a good sign that everything is going to plan. You can see in the flask, just barely, that it's kind of a yellowy goldy orangey mixture in there. So that should be turning darker and darker and darker as the reaction progresses. Now if you're wondering about my condenser setup, just a bucket down there with a little fish pond pump that I'll show you after the distillation. One thing to keep an eye on is that when it starts foaming, that it doesn't go above halfway. If it goes above halfway, turn down the heating immediately, else your entire reaction chamber will clog up with potassium bisulfate, which won't be nice. Or should I say potassium bisulfate? Sorry. I've just turned the stirring down because the stir bar was just going insane, and yeah, that was a problem. So let's just explain what's going on here. So we added in the water, which will just be a reason for it to become an azeotrope, which means that it's inseparable with water. So that means it's 68% nitric acid and 42% water, and that's the azeotrope of nitric acid. That's how it boils. So then we added the potassium bisulfite and the sulfuric acid, and that reacted to produce the potassium bisulfate and also the nitric acid. Now the reason why the nitric acid is coming first and not like loads of other volatile side products and stuff, because nitric acid is the most volatile thing in this entire apparatus. So that's why it comes over first. Now obviously there's a load of watery things in there, it's obviously very contaminated, but that's why we get some lovely nitric acid in there, not loads of organic compounds. Now you might be thinking, is it a problem if I use one-shot drain cleaner instead of professional grade 98% sulfuric acid? No, it doesn't matter an ounce. Most of the organic produce from that will stay in the pot, in the boiling flask, because as I said, this that's coming over, nitric acid and the water, are most volatile products anyway. Now if you're curious as to whether this is actually nitric acid, at the end I'll show you a nice trick to verify if this is actually nitric acid.
One eternity later.
So, we've just got to a stage where you can see there's gas coming out of the vent. And you can also see faint orange tinge in the condenser. So, and also quite a lot of crude nitric in there. And not a lot of reaction stuff in there. I'm just going to let this go a bit. This will be when foaming starts to happen, when it starts to solidify. This is the time to keep an eye on it. This is a sign that we're nearing the end of the first part of the procedure, because if I can try and find it, we're foaming here. And that is shooting off a lot of gas. There goes the top.
So a stopcock.
A stopcock blew off. So we're just going to turn off the heating and stirring and just let this cool for a bit. Right. So what I want to do now, turn off the water and just now we want to disassemble everything, because if you don't, then it will start to jam. Obviously, make sure you're doing this. You're wearing a respirator, gloves, and goggles.
So here is our extremely crude nitric acid that's just distilled. Just make sure we're in frame. We're going to redistill this in a second. Hopefully you can hear me. Now you might be wondering what we can do with this solid sulfites in here. It's very, very soluble in water, so we can just pour in a load of water. Turn on stirring while we do this. Just pour in enough to dissolve everything here. We're just going to let that cool for a bit. Now, this is pretty much pure sodium trisulfate. You can keep this. I'm probably going to. I'm just probably going to put it in a flask or bottle for now, and we can recrystallize it or something at a later date. But for now, just gonna let it cool, put it into a bottle, and so the rest of the glassware, you probably just want to wash them in a bucket of distilled water or something that's just a bit more level, just so we get everything off. Obviously do this outside or in a fume hood, because obviously there's some nasty materials in there, for instance the nitrogen dioxide and stuff. Now one thing we can do when we let that cool is verify that that stuff in there is actually nitric acid. You can do that by getting a copper coin or something. I've got a penny in there because I'm poor, and and some nitric acid. You can just do the same basic test over the coin, and it should change colour and start fizzing. Yeah. And that should eventually turn green. And start releasing some nice orange gas. So yeah, while we wait for that to happen, yeah, it's starting to turn blue. A tint of blue, which is copper nitrate. Very good sign. So that is crude nitric acid in there. But what I'm going to do now is just wash all of this glassware in some water. Just make sure everything's ready to go for a second distillation. What I'm going to do, wash all my glassware now, and I'll be back when I'm done. I'm also going to transfer this into a bottle for safekeeping.
Eventually.
So, now that everything's cleaned up, we can start to assemble another distillation apparatus. Now, I made an oopsie, which was that I accidentally put 200 milliliters of water instead of 100. So we will have to distill it again after this one, just to get rid of that excess water. But that's not a big deal, as when we've completed one distillation, we can just kind of put it back in. A bit of progress on the penny. It's created this lovely teal coloured solution, which is lovely jubbly. We can put this here or something for now, and we can get back to reassembling the distillation apparatus. So here we go, here's a time lapse. As you can see here, I've constructed another simple distillation setup. We're going to distill our crude nitric acid here until it reaches 130 degrees, then we'll swap out the receiving container. Then we'll redistill it because I made the oopsie, but you don't have to redistill it if you've done, if you've put actually 100 milliliters of water in. So, we've also put the stir bar back into the contraption. Very, very useful. So I'll just pour this in. We'll start at the top. And off we go. So when the mixture hits about 118 to 120 degrees, we swap out the receiving container for another one. And obviously, because I made the oopsie, I'm going to pour this straight back into the boiling pot so that we can get another distillation. Now you might be wondering why we can't go above 68% with this setup. The reason why is because 68% is the azeotrope, so it can't go above that. The percentage can't go above that. You can already see that it's starting to turn a bit yellow from the nitrogen dioxide coming off it. That's a good sign that it is working. We can already see a bit of reflux happening on the sides of the flask. Now when you're doing this, you don't want to distill until there's nothing left in the boiling flask, because that's bad and that will cause lots of nasty things to happen there. As you can see, it's turning quite orange, so there's quite a lot of nitrogen dioxide gas in there. Have your respirator at the ready, if gas starts coming out this vent. I just saw a little dribble of reflux happening from the adapter, which is a good sign that things are starting to happen. Now, it's a good idea to have a stir bar in there or some boiling chips or something to prevent bumping. I have a stir bar because that's what I have. I don't really want to sacrifice a round bottom flask for this. Although if you are staying, say, sulfuric acid, it is pretty much mandatory to have at least some boiling chips, some sand or some ceramic things in the bottom, just to make sure that it doesn't bump and splash everywhere. So just got the first drips of nitric acid coming out of here. I also noticed some gas coming out a bit earlier, so I'm going to put on my respirator. the reason why we're changing the receiving flask out is because we need to make sure that we've got the azeotropic solution, which means it cannot be separated by distillation. So that's why we're doing that. So we should be about ready to do that, and we start collecting our pure nitric acid, our azeotropic nitric acid. Now we can keep the other stuff. I'm just going to put it into this bottle because we can always use it for testing purposes. Left to go now. I'll just show you in the boiling pot. There's not much left in there, so still we've got plenty to go until we can stop the distillation. I've got a bit of nice nitric acid in there, about 75 millilitres I should say. I'm just going to continue this until it's all distilled. Turn it off now to keep the stirring going, so that the heating level gets time to cool down and the mixture does it at the same time, because obviously, as I said, I don't have a lap jack. Yeah, so wait for these final bits to come through and we can disassemble the apparatus. As you can see, the condenser was just filling up with orange gas, so yeah, that was a good time to kind of stop. As you can see, the last few drops are coming through. That means we can turn off the water. Well, we shouldn't really turn off the water. Leave the water for a bit, although we can turn off the heating mantle for now, as everything cools down. Right, everything for the distillation has finished, so we're now going to put this beaker under it while we pour our freshly made nitric acid into this bottle. I managed to get around 100 millilitres of acid, which is quite good. There you go. Yeah. As I only made 68% nitric acid. So you can use this for a lot of things, including making some rather interesting compounds. So yes, let's just put what we managed to get during this process down the table. We managed to get some 68% nitric acid, some potassium bisulfate solution, and some stuff that we can purify, and some kind of testing purposes only nitric acid as well, which is lovely. So yeah, let me take this down and I'll film the outro. Thank you very much for watching this video. If you did enjoy it, please make sure to smash that subscribe button, it would really mean a lot. Also turn on post notifications to receive instant notifications of when I upload my videos. Also smash that like button to let me know that I'm actually making decent content. So thanks very much for watching. I will be potentially doing a sulfuric acid distillation video soon. I'm definitely doing a sodium extraction mini-series. So I'm focusing on sodium extraction without electrolysis, so going through the sodium magnesium oxide aggregate process and dioxane, and then doing all of that stuff, which will be quite fun. But yeah, other than that, thanks very much for watching, and I'll see you in the next one. Bye!